All right. Hello. In this video, we're going to be talking about molecular structures, specifically drawing them. There are a few notes, though, that you need to write down first. So we're going to start off with some bonding rules that you're going to need to know. So ionic bonding rules is first. So pause it, write that down. All right, I'm going to assume you've done that. And we're not going to do anything more within these. You need to know that these are the rules, but we're not going to be drawing any ionic compounds. So let's roll over to covalent. Covalent bonding rules are going to be a little more involved because we're actually going to be drawing some of these. So yeah, pause and write these down. Okay, this time I'm actually going to talk about it. All right, so covalent bonds always require two electrons. That's from the last section. You should already know that. Where one is coming from each element. Okay, every non-metal or everything that's forming covalent bonds can make up to 4 bonds. Nothing can make 5 or more. Okay, and there's only 2 elements that will consistently make 4 bonds, and that is silicon and carbon. Silicon you are not going to be dealing with in this class because it's a metalloid. But carbon you're going to be dealing with a lot. So you definitely need to know that carbon can make 4 bonds. We'll do a little bit with that as we get going. Okay, and then multi-bonds will, in this video, or maybe in the sequel video, we will do a couple of practice drawings where we actually draw out some of these. So I'm going to pause this, pull up the next section of notes, and that's pretty much it for this spot. So, yep. I missed. All right, and we are back. Okay, so these are the 4 kinds of molecular structures or molecular diagrams that we're going to be talking about. Okay, the only one that you guys are really going to be drawing a ton of is the second one here, Lewis structures. I'm going to show you one of each of these. Specifically, I'm going to show you this molecule and what it would look like in each of these. And these are more to do with possible bonus questions, I would say. Simplified Bohr diagrams are exactly that, simplified Bohr diagrams. The water molecule I drew in the last video was an example of a simplified Bohr diagram. Lewis structures, but molecular Lewis structures, or Lewis structures for compounds, are the main thing we're going to be focusing on. I'm not going to spend too much time on that. Structural formulas replace the circles in these with lines. These take a lot less time to draw, but they require you actually know what you're doing already in order to actually do that. By the way, the limitation on this, it really only works for covalent. You can't really do ionic compounds with this, but you can do ionic compounds with... You can't really do ionic compounds with this either. So Lewis structures will kind of lock you into a grid. Structural formulas, you have to know what you're doing. And skeletal structures are only used in organic chemistry. So those of you who go on to take chemistry as sophomores or juniors, we will do quite a bit because our last unit of the year is organic chemistry. And we're basically just drawing skeletal structures. That's it. It's the entire quarter. We're just trying to figure out how skeletal structures work. Or rather, trying to figure out how naming works. So, yeah, that's pretty much it. Hopefully you have this stuff written down because I am about to pull up a white screen and I'm going to draw one of each of these for this molecule. So pause it if you haven't done that yet because this is all about to go away. Going once, going twice. So, all right. I probably should have done slightly different color scheme on a couple of these, but we're going to roll with it. So I'm going to go through and identify these first. I would recommend that you draw out at least this grid with the formula in the center, and you can write in the names of each of these as we go. I'm not going to write those down because the spelling are on your notes in front of you, so you should have those. So first one over here is simplified Bohr. This is a simplified Bohr diagram for C2H6. So there are 2 carbons in the middle. Hydrogens, there we go, are spread around the outside. And the electron shells, you can see, have overlapped to fulfill the octet rules. for the carbons, and each hydrogen has 2. This is like the water molecule we did the other day. This is a molecular Lewis structure. This is what you guys are going to be doing. So each atom is supplying 1 electron, and those electrons are forming what's called a bond pair. So carbon is making 4 bonds, hydrogen is making 1. And the bonds are a little clearer here. This is a structural formula. You'll see this is very similar to this, but instead of circles with the dots in the center, this is just lines. Multi-bonds are way easier with this than they are up here. But again, we're not going to be doing much with these in this class. And then this is the skeletal structure for C2H6. That's it. It's definitely the easiest, but you have to know the most about what you're looking at to figure this out. I'm going to go ahead and say each end of this line represents a carbon, and we don't draw hydrogens in skeletal structures because there's a friggin' ton of them. And typically when we're doing skeletal structures, we're doing very large molecules, like something that has 5, 10, 15 carbons in it. So you can only imagine how many hydrogens would be in that. And that's a fairly small molecule. So yeah, we use skeletal structures when we're doing really big things. Not as big as proteins or DNA, but big molecules for organic chemistry. So yeah, simplified Bohr, molecular Lewis, structural formulae, and skeletal structures. And that's pretty much it. Now let's move on. Actually, we're going to end this video here. I'm going to stop this video here, and we'll make a second video that's going over specifically molecular Lewis structures. So get this stuff written down if you haven't, and we'll call it adieu here.